Moving on to the next topic, the topic number 4. This is continuation of the previous topics. So I would request you to watch the videos in continuity. So please watch the video number 1, be thorough with it, and then move to the next video. And one more important thing is when you're watching these videos, have your rough paper, rough book with you, try solving the problems, and then check the answers because all the answers are available in the presentation. So check the method, check your understanding, and check the answers, the answer keys. Now, the fourth topic, you have to use second derivative test. What is second derivative test? Now imagine you have a function, derive it once, you will get first derivative. Then equate that to 0, you will get the critical numbers. And if you derive this derived function again, it is second derivative. So now there is one thing, the second derivative test, what it says is, you need to derive one function. Okay, we get it, equate to 0, find the critical numbers. Say you got minus 3 and 2. Okay, two critical numbers. Then what you need to do is substitute these critical numbers instead of x in the place of second derivatives. Instead of x, put these critical numbers. Wherever the equation will be there, don't put x, put critical numbers and solve. And now what it says is, if you get greater than 0, if you get a positive value, remember, if you get a positive value, it's a local minimum. Let's see why. Because in second derivative test, if you get a positive value or number greater than 0, it open upwards. See, a parabola, when it's positive, it will be opening upward, isn't it? But the value over here, the maximum, absolute minima or maxima, it's minimum point, local minima. And similarly, if you get less than 0, that is a negative value, it will open downwards, and this over here is maximum point. Okay, so this is the things. And then so over here you will understand what is the maxima and what is the minima. So now imagine minus 3 you substituted and got greater than 0, so that means that is the local minimum, maximum, sorry, greater than 0, it's minimum. So that is the thing. Same way, substitute another critical number, whatever the critical number is. Imagine 2, put it in the second derivative, you'll get an answer that should be maximum, or it should be positive or negative. Based on that we will solve. We will do a problem quickly, you'll understand much better. This is the function, let's derive it. This is the basic thing. So it'll be 4x to the power 3 plus 12x to the power 2. Now don't do anything with 1, it'll be 0 because there is no x. Now let's use the calculator and find the solutions. Mod 5 and 4, that is for cubic. The answer is 4. X square is 12, and there is no x and no number, so it's 0 and 0. The answer is minus 3 and 0. So you got the critical numbers minus 3 and 0. Now you need to derive it again. Let's do the derivation. F double dash of x. It'll be 3 times 4 is 12, x square plus 24x. Now all you need to do is substitute these critical numbers over here. Okay, I will put this minus 3 over here, so 12 into minus 3 the whole square plus 24 into minus 3, that is equal to positive value 36. So now whenever you have a positive value, you will have a local minimum. You can see f double derivative minus 3, the value is greater than 0, so it is a local minimum. What about the first one, another 0? Put 0 and 0, it will be 0. So now over here, this is inconclusive. That means you don't have the exact answer. So over here, they have just left like this because over here, what happens is if you had graphed, it is neither, it might be neither, it is not local minimum maximum. That is the thing. So if you want thorough understanding, if you want to know thoroughly about the graph, you can, do the method which we employed. Write the critical number 0, sorry, it will be minus 3 first and then 0. Take the test values, substitute in this, and you will get plus, minus, minus, or plus, so on. So that is how we can do it. Same way you can solve the others. It's very simple. Just make sure you find the critical number, put it in the second derivative. Over here, you have only one critical number, put it over here, and it was greater than 0, so it's local minimum. Similarly, over here, the equation might be complicated. Only thing is you need to derive it. Over here, you should use the product rule. It is u dash v plus uv dash over here as it is, and then simplify how much you can, find the critical numbers, and then you need to put double derive again over here, double derivative, it'll be product rule, and then substitute this critical number over there. So it was less than 0, that means it's a negative value, and you have local maximum. So this is how you can solve it. Please go through the other problems, solve it by yourself, and then check the answers.